Dear friends, dear colleague, welcome back to the Mangano Digital Academy. Welcome back to the Essential of Digital Dentistry. In this short video, we will talk about printing zirconia. This is one of the new frontiers of digital dentistry, one of the new challenges and options also that we have as digital prosthodontists, for example, but also as digital surgeons. As I told you, digital dentistry is made by and essentially based on 4 steps. The data acquisition that brings us from the real to the virtual world by means of beam computed tomography, intraoral, desktop, face scanner, digital condylography. We collect a series of wide data, and these data then are sent to a computer-assisted design software. It can be a prosto software, a surgical software, an ortho software. The lab technician usually elaborate this data and create a project, and this project is then sent to the computer-assisted manufacturing software and the milling unit or the 3D printer for the shaping or the making of this project, so the production. And here we go from virtual to real once again. And then there's the clinical application. So we have different applications for the different fields. For example, in surgery, we can make surgical guide. In prosthodontics, we can make or shape fixed or removable prostheses. In ortho, we can make devices like a liner or, customized device, retainers, everything. So basically, we have the clinical application. In this case, we try to talk about the 3D printing of zirconia. And since it's a totally new field, we try to investigate the quality of the restoration made by or printed in zirconia in 3D, but also we try to understand the mechanical resistance and reliability of this new material, because after all, this is a totally new material. It cannot be really compared with the milled one. So we made this very easy study in the design in order to evaluate the differences of milled and 3D printed zirconia blocks under uniaxial compression, uniaxial loading. It's only one kind of analysis. Of course, we are going to complete this analysis with a Weibull analysis and flexural strength analysis as well, because it's also very important. The technology used for 3D printing, in this case restoration, is the lithography-based ceramic manufacturing, LCM. That is a proprietary technology by Lithoz. This Austrian company is one of the most important companies in the world in the field of 3D printing of ceramics, not only zirconia, but also lithium disilicate in our field, for our application specifically, but also in the medical field. So the dental field is a little field compared to the medical one. The point is that now we are able, through this machine like Cerafab S65 by Lithoz, to print this restoration. It's something totally new. We didn't have this option 10 years ago. And the lithography-based ceramic manufacturing process is based on layer-by-layer curing of a ceramic suspension using visible blue LED light. Basically, the ceramic suspension, in this case Lithacon 3Y, consists of 3% molar yttrium-stabilized zirconia ceramic powder, so it's zirconia, and photocurable resin, additive for optimal processability. So the STL file of the crown is split in layer by the computer and projected layer by layer onto ceramic suspension, which is hardened and cured by photopolymerization, and it forms the so-called green body. This green body consists of the shape-giving polymer and obviously the zirconia particle fixed within. Then after 3D printing, the green bodies undergo post-treatment, so they are cleaned of the excess of material and in a cleaning fluid, dedicated and proprietary fluid in cleaning station, and then, most important thing, sintered in order to obtain pure zirconium oxide in the thermal post-processing. Sintering is carried out in a furnace and at a very high temperature, like 1450 degrees, with a dwell time of 2 hours under a normal atmosphere and without increased pressure. In this way, we can eliminate all the resin. We can obtain only a dense, more than 99.4, 99.6% amount of zirconia in these blocks and in these restorations. So the sinterization is very important in order to obtain the pure zirconia and to eliminate the photopolymer and the resin along this time with the temperature. This is a very easy process if we can think about it, but the point is that the machine is not easy at all. The characteristics of the machine are very advanced. This is a very powerful machine, a very powerful tool, and the dental laboratories, the biggest dental laboratories and the big dental companies are now investing in this machine because this is a game changer, definitely. Let's think about, for example, our 3D printed zirconia implants, for example, made by the companies, or also 3D printed root analog implants, for example, or 3D printed meshes for bone regeneration in zirconia. We have several options in the surgical field, but probably the main application is in prosto for the fixed restoration. And here the characteristic of this ceramic suspension. If we watch the scanning electron microscopy, we see the layers and we see the density. The density can be over 99.6%, and it is very promising from this point of view. But in our study, what we did, basically, we created we fabricated 20 zirconia blocks. 10 of them were 3D printed, the test blocks, and 10 of them were milled using a conventional milling unit, the one I have in my clinic, the Roland D52. And then we evaluated the behavior of these blocks under uniaxial compressive loading using the state-of-the-art test in this in vitro comparative study. And what we found is that under mechanical compression, 4 of the test sample reached failure, whereas all the control sample did not reach failure. This is one of the first indication, but we were, of course, at the limit of the load cell. However, we have to say that 3D printed sample, the ones that did not break, revealed very interesting properties. For example, a better module of elasticity and a lower tendency to deformation under compression when compared to the milled ones. And considering that the forces in which the test sample reached break and failure was very high, then we can consider that the results were very interesting despite of the limits of the study, the experimental setting, the in vitro design, and only one type of force applied. We can say that yes, there's a difference between the test and control sample, but both samples behaved very well. This article has been published recently online in the Journal of Dentistry. And here the scheme of the uniaxial compressive loading. 4 of the test blocks reached failure under compression. No one of the milled zirconia blocks. Despite of it, the 3D printed zirconia blocks revealed very interesting properties. And here we can see, if we watch the scanning electron microscopy, these blocks, we find the microporous surface of the 3D printed test samples has clearly a direction of the sample printing indicated by parallel lines. And we can see inside some porosity, and probably the key to control the failure is to try to reduce or control this porosity, that is something unavoidable from one side if you print it. So in order to reduce this porosity, that of course doesn't exist with the milled sample, we can of course improve the printing process. But also we have to say that we can evaluate the behavior of the sample that underwent failure, and we can see the characteristic, the mechanical and the physical characteristic of these samples, and we found some very interesting point in favor of the 3D printed samples as well. So yes, finally the conclusion is probably it looks that the milled one are more reliable, but we should not underestimate the positive things related to 3D printing. So everything is new, and we need to go deeper in order to understand better the property of the 3D printed material that is totally different from the milled one. So thank you very much for your kind attention.